Lesson 6 is titled Choosing a Factoring Method. What it is in practice is taking an expression and making sure you have done all possible factoring. So, determine if it's completely factored, and if it isn't, factor it. There are two terms in this first example, 2x and x squared plus 4. 2x is a monomial. We can't factor a monomial. And x squared plus 4 have nothing in common. And it's not a difference of perfect squares. That is sum of perfect squares, which is nothing. There's no pattern. It doesn't do anything. This is factored. There's nothing we can do to it. In this example, we have 2x and 6 as a term, and x plus 5. 2x plus 6 factors. They have a common 2 that can be taken out. I can take 2 away from 2x and 6. X plus 5 doesn't factor, so it just comes along for the ride. And 2 times x plus 3 times x plus 5 is the factored form. Factor completely. And you'll see I'm leaving lots of space on these examples. So, I don't want to type. I wish to draw. The first thing you want to look for is anything that is common to all the terms that you can factor straight away. You want to do that before you do anything else. So when I look at all these, I'm seeing a 2 that is common to everything. I'm seeing an x that's common to everything. And further, since there are 3 terms here, and I know that I don't like the first term to be negative if at all possible, I'm going to say we can take a negative 2x away from all of these. That would leave y squared, because negative 2 divided by negative 2 is 1, and the x's are coming out. In the middle term, 16 divided by negative 2 is negative 8. And in the third term, negative 32 divided by negative 2 is positive 16. So now I have negative 2x times the quantity y squared minus 8 plus 16. The negative 2x I can't do anything with. It's a monomial. The trinomial in parentheses I might be able to factor. Now, we can do this brute force by saying two numbers that multiply to make 16 and add to make 8. But first, we should probably check if it's a perfect square trinomial. It would make our lives a lot easier if it is. So the first term is y squared. Its square root is y. The third term is 16, positive. Its square root is 4. 4 times y, oops, I also forgot to put my y on the 8. That should be a minus 8y, my apologies. 4 times y is 4y, doubled is 8y, and that is the middle term. This is a difference, or this is a perfect square trinomial. It's y minus 4 quantity squared. Now, what if you don't recognize that? And you wind up going, okay, well, two numbers that multiply to make 16 and combine to make 8 are 4 and 4. And they're both negative because the middle term is negative. Well, then you would write this. And now you should see that you've got that y minus 4 term doubled. So you really do need to write it as being squared. Yes, you would lose credit if you stopped here. That's not enough. You must take it to negative 2x times the quantity of y minus 4 squared. Okay. 2x squared plus 5x plus 4. Is there anything that can come out of all of that? And the answer is no. No numbers come out of 2, 5, and 4, and there's not an x in all of them. So this seems to me like if we're going to be able to do it, it's going to have to be a formatted problem where we're going to go, okay, A is 2, B is 5, C is 4, AC is 8. Two numbers that multiply to make 8 and add to make 5. Numbers that multiply to make 8 are 1 and 8. That's 9. 2 and 4. That's 6. And that's it. This problem, this example, is what we call unfactorable. We actually cannot do anything to it. Up next, if you look at 3, 15, and 12, I'm thinking if 3 comes out. And they all have n's, so I'll take the smallest one, n squared, out. 3n to the 4th divided by 3n squared is n squared. 15 divided by 3 is 5. N cubed take away n squared is a single n. And 12 divided by 3 is 4. N squared take away n squared, well, they're gone now. So, is this a perfect square trinomial? Because the 3n squared is a monomial, it's just going to come along now. Look at your trinomial. Well, the square root of n squared is n. Square root of 4 is 2. 2 times n is 2n, double it is 4n, and I've got 5n, so it's not a perfect square. That doesn't mean it's not factorable. Now we have to ask the question, are there two numbers that multiply to make 4 and add to make 5? And that would be 4 and 1. So the 3n squared comes along. We're going to have an n and a 4, an n and a 1. And the sign will be the sign of the middle term. So both minus. That is factored. So when we look at this, I'm thinking factor out of 4x. That looks to be the common thing, except it's not. It totally isn't, because 18 doesn't divide by 4. So how about a 2x? 4 divided by 2 is 2. X cubed, take away one of those x's, is x squared. 18 divided by 2 is 9. X squared, take away one of the x's, is x. And 20 divided by 2 is 10. The x's are gone. Here we have a trinomial. It's definitely not a perfect square trinomial because 2 and 10 aren't perfect squares. So the question is, do we know two numbers that would multiply to make 20, 2 times 10, and add to make 9? And we do. 4 times 5 is 20, and 4 plus 5 is 9. So this we have to do by grouping. The 2x carries along. The 9x gets split up into 5x and 4x. We look at the first 2 and last 2. 2x just carries along. When I look at these first two things, the only thing in common is x. So pull x out. That leaves us with 2x plus 5. When I look at 4x and 10, the only thing in common is 2. 4 divided by 2 is 2. X carries along. 10 divided by 2 is 5. That means our answer is going to be 2x times the quantity, 2x plus 5, times the quantity, x plus 2. And last example, there's a common p in both of these. So if I take that out, I'm going to have p to the 4th minus 1, which is the difference of perfect squares. P to the 4th is a perfect square, and 1 is a perfect square. The square root of p to the 4th is p squared. The square root of 1 is 1. So we get p times the quantity p squared plus 1 times the quantity p squared minus 1. Except that last thing is another difference of perfect squares. P squared is a perfect square, 1 is a perfect square. So this last set of parentheses has to get broken up into p plus 1, p minus 1. Now this is fully factored. Okay. There is a table on page 568 of your book, and I'm not going to go to it right now. You can certainly look at it on your own. And it basically will walk you through the easiest to hardest things to look for in order to factor. So I strongly recommend you go and at least take a look at that table.